Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of dilation representations. This is standard 8.3c in the great state of Texas, and we are using item number 12 of the Redesign Practice Online STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on our own, unpause it, and we will look at our answers together. So we've got a table showing the coordinates, xy coordinates of two different triangles, and they are dilated with this origin as the center of the dilation. We need to find the best rule. Now we've been looking at tables and we've been looking at rules ever since like the 2nd grade, right? So the only slight difference is here we've got actual xy coordinates. We could graph these if we really wanted to, but we're not even necessarily trying to find which rule is being applied here. We just need to find the rule, and we don't necessarily need to look to see whether it's a rotation or a reflection or anything like that. So what we need to do here is we need to match up our coordinates here, right? So the 2 is going to be dilated to the 10, so that's the first x coordinate for each, right? The 3 is going to be dilated to the 15, 5 is going to be dilated to the 25. Now, in a traditional table like this, right, when you get your rule, right, the rule equals, and it's only one set of numbers, right? So you get your x's over here, your y's over here. The rule might be plus 7. So you would just take your x and you would plus 7, you would get y. The thing with these dilations is it is possible to have, there's two sets of numbers, different rules, right? So this 2 goes with this 10. Now, as you can see, looking at all of our rules, it actually is the same for all of them, but that's not always going to be the case. Sometimes you could have one rule that acts for your x coordinate and a different rule that acts for your y coordinate. So you just need to keep that in mind. All right. So what happens when we go from the first x to the second x? You know what? Let's just use what I have over here. Instead of x and y, I'm just going to call that x sub 1 and x sub 2. Because if we look at it like this, look at this, 2 goes to 10, 3 goes to 15, and then 5 goes to 25. All right, so if you kind of push them together like that, now it becomes pretty obvious. All right, so we're getting bigger. We can either add, right? So this could be a plus 8, but then that would be a plus 12, and that would be a plus 20. Okay, so that doesn't follow any rule. We could do a multiply by 5, and that works. Look at that, 2 times 5, 3 times 5, 5 times 5. Now, since they're all the same, let's see if that works. So this is going to be a times 5. Let's see if that works over here. If we get the two different y's, y sub 1, y sub 2, and that's going to be negative 2, negative 10, negative 6, negative 30, negative 4, negative 20. Multiply by 5. Yep, that works. Yep, that works. All right. So that definitely works for all of those. So my rule is going to be multiply by 5. Now, the question is how do I write that? Well, what we have is we have this xy, this little arrow, and then it moves over to some type of coefficient here modifying our x and our y. So in this case, it's 0.2 multiplied by x. So this is times 0.2, which is actually the same as dividing by 5 if you want to get fancy about it. So that's not what we're looking for, but if you for some reason wanted to divide by 5, right, I guess going from right to left instead of going from left to right, then I guess you could maybe see that, but that's really not what we're looking for here. There you go. There's your times 5, because it's just got 5y, 5x. This is times 8. And then here's your times 10 down here. All right, so you don't really need any of these down here. All that being said, our answer is going to be B, 5x, 5y.